So this is our titration, okay, for the redox reaction. This is basically what you're expecting. Basically what you're expecting. Here is iodine solution according to prescription. Iodine dissolving potassium iodide. And the reason why dissolving potassium iodide was to ensure that iodine dissolves in water. Basically, iodine does not dissolve in water on its own, right? So it doesn't dissolve potassium iodide. So this iodine solution, which today will be acting like the base in titration of this. Then this is sodium thiosulphate. Sodium thiosulphate today will be acting as the acid. Okay. Now this is our starch indicator. Yes, our starch indicator. Yeah. Yeah, of course, this is our pipettes and our chemical flask for our period. This is what we expect for question number 1, 2022 Y. So the first thing you do is you pipette your iodine. Pipette your iodine using this pipette. Stock up 25 mils. 25 mils. Okay, so this is our 25 mils of iodine. Alright? We're going to pour it into the conical flask. Just release your hand like that. Okay. So one of the precautions is that you don't blow. Alright? Just pour it like that. Alright. So you got that. Then you now pour your sodium sulfates into your burette. Do that carefully until you get to the zero mark. So let's pass zero mark and bring it down. There we are. Precaution again, you remove your funnel after pouring. So I'll give you 2 precautions. One is not blowing the vents, right? And secondly, remove your funnel. So now this is our iodine. Okay, our iodine. This is our potassium sulfate. Then you add your starch indicator. Look at this. What will happen now? Those 2 drops. 1, 2. As the starch indicator turns black. Of course, the reason why it turns this blackish is because this starch, this iodine, test for starch, right? Gives a blue black coloration. So let us titrate and see what we're going to make out of this. Are you seeing it? The color is changing. At this point, you become more careful. Okay. You can see now our color line is now what? Colorless, right? Unlike what we had earlier. You see it? Those stains are the stains of the starch we got from our solution. So at this point, we take our reading. Our reading here is 7.2. 7.2. So our rough titer 7.2 cm3. So we repeat this like 4 times, rough, first, second, and third. We will do that. Alright? So this is a continuation from where we stopped, the titration. This is how you represent your table of value. It must be in this pattern. Of course, you must tell the examiner your volume of pipettes, which will be what we use is 25 cm3. That is very important because it represents your volume of phase, VB. Alright? So you have a table like this: readings, first titer, rough titer, first titer, second titer, and then the third titer. Then we have the final reading, the initial reading, the volume used eventually. In the rough titer, in the case we have here that we demonstrated earlier in the previous video, the initial reading is 0.00 because we fill your purette to the brim here, so it's 0. When we run the titration, we will get 7.20. To subtract this, you're going to have the volume for rough titer at 7.20. Remember, I emphasize on using your values in 2 decimal places. Yes, must be consistent. And try not to alter. YX standard, any alteration minus 1 mark. Any alteration minus 1 mark. So you must be very careful. Use value, no pencil. Now, we didn't refill, we continue from there. It simply means that when we stop at the initial one, serve as the initial to the next titration, which is 7.20. We run the titration, we ended at 13.0. You subtract it, you're going to have 6.4. We continue with 13.60 as initial, run the titration, we ended at 20.20. Subtract, we have 6.6, and so also we got 6.5 as demonstrated. Now the first question will always be calculate the average volume of A used, or calculate the average volume of X used. Whichever description Y we choose, we are going to now say V is equal to V1 plus V2 plus V3 whole by 3. So there is no mark for stating that formula. There is no mark for saying V1 plus V2 plus V3 by 3. So to save time, you can go directly to pick 3 concordant values. Concordant. 3 concordant value. Yeah? 3 concordant value means 3 values that are closely related with at least plus or minus 0.2. Do you know that if for any reason I pick 7.2 in this averaging, I'll lose the mark for averaging because the values must be concordant. They must be very close with at most plus or minus 0.2. And here we have 6.4, 6.6, and 6.5. Divided together are 6.50 cm3. Now this is how your answer should look like for the first question in your titration. We are going to look at a typical example of how the other questions will look like and how we will attempt them. Okay? Alright. Okay, so this is the typical question you'll be expecting in your 2022 chemistry wide practicals. And then we are told that A is a solution containing 15.8 gram per dm cube of sodium thiosulphate. Was obtained by dissolving 9 grams. Okay, B is another question. B was obtained by dissolving 9 grams of an impure sample. Why is it called impure? Impure sample of iodine in aqueous potassium iodide. It is impure because we have potassium iodide. And we add potassium iodide to increase the solubility of iodine. Iodine on its own is slightly soluble in water. So to increase its solubility, dissolve it in aqueous solution of potassium iodide. And the solution was made up to 1 dm cube. Invariably, you could say that it is 9 grams per dm cube of impure iodine sample. 9 grams per dm cube of impure iodine sample. Now, in the instruction, put A into burette, prepare 20 or 25 cm cube of B, use starch indicator, repeat the titration to obtain concordant titer value, tabulate your reading. and calculate the average volume of A used. Okay, we've already seen how to do that. We've seen how to get our average volume of A used from the table, right? Yes, we've established that. So now we are going to go into the calculation proper. This way the math lies. We are given the equation for the reaction, and for the equation of the reaction, since thiosulphate is serving as A, so this is going to be Na is 2. That's the mole ratio of acid is 2, while mole ratio of iodine, which is about the base here, will be 1. So we're working with Na to NB1. That's what we're going to work with. So the question now is calculate the concentration of A in mole per dmg. Now we have two formulas we consider from. One is to use mass in gram over molar mass. The second one is to use CaVa over CbVb equals to Na over Nb. But because the parameters given here satisfy, we are given the mass in gram per dmg of student thiosulphate, right? And then we can calculate the molar mass of that. So you can simply use the molar concentration, that is concentration in mole per dm cube, of course, of A will be mass. This mass must be in gram per dm cube all over molar mass. The mass has been given to be 15.8. The molar mass, we can calculate it. So let's get the molar mass. Molar mass of this is going to be what? Sodium is 23. So 23 times 2. Alright? Molar mass. Then plus sulfur is 32. So 32 times 2 plus oxygen is what? 16. 16 times 3. This will give us 48. This will give us what? 64. This will give us 46. When you add in, what do you have? Gram per mole. 158 gram per mole. But because of space, 158 gram per mole. So our concentration now is equal to, our mass is 15.8 all over 158. This is equal to 0.1, right? That's 0.1. But we're not going to leave our answer as 0.1. The standard way of leaving the answer of concentration is in 3 decimal places. That is 0.100 mole per dm. Yeah. So we are done with the first question. We are saying calculate concentration of A in mole per dm using simply mass over molar mass. Our mass is given in the question 15.8. 15.8. Our molar mass is 158. Divided to 0.100 mole per dm. Then the second one, the B part, of course this is A. The B part is saying concentration of iodine in B in mole per dm cube. How do we get the concentration of iodine? We are going to use this formula CaVa over CbVb equals to Na over Nb. So if you are using this formula, our Ca we've gotten it to what? 0.1 times. Our Va, we got our Va earlier to be 6.5. 6.50 divided by what's our Cb? That's what we're looking for. Okay? Cb unknown times our Vb is what? 25 as established from the the volume of the pipette. That's why you must indicate the uh, volume of the pipette used. So equals to our NA is what? 2. Our NB is what? 1. So let us now make CB subject to the formula. Our CB will then be what now? 0.1 times 6.5 times 1, all divided by 25 times 2. CB equals what? 0.013 mole per kg. Now this answer is called question concentration of iodine in B mole per kg. So we are going to look at the last question before we round up. The last question. So from the yes, yeah. So from the question, you notice that we are told that B was obtained by dissolving 9.0 grams of an impure sample of iodine in aqueous potassium iodide. And now the question is saying that we should get percentage by mass of iodine in the sample. Alright, so to do this, we must get the mass of iodine. This is the impure mass of iodine. Alright, so we must get the pure mass of iodine. And to get the mass of iodine, we use the relationship that said that concentration or molar concentration, of course, in mole per dm cube is equal to mass over molar mass. So we are looking for this mass. To get this mass, we make this subject formula. It's going to be mass of iodine will be the concentration, of course, in mole per dm cube multiplied by molar mass. You will recall that we have already gotten our concentration of iodine as 0.013, right? So 0.013 times molar mass of iodine is given to me 127. But iodine is a diatomic molecule. So it is iodine 2 multiplied by 2. So do that. What do you have? 0.013 times 1717 times 2. So we have 3.303. This is in gram per dm cube. Now this is the mass of iodine. The mass of iodine. But the question didn't say get the mass, it said percentage by mass. And then this is the impure sample. This is now the pure sample. So it's going to be 3.303 all over 9.0 times 100 over 1. What's the answer now? 36.7 what? 70%. So now this is the percentage by mass of iodine in the sample. So this is what we're expecting tomorrow. And we stop here. I wish you all